Question 171. Your company has a Google Workspace account and Google Cloud organization. Some developers in the company have created Google Cloud projects outside of the Google Cloud organization. You want to create an organization structure that allows developers to create projects, but prevents them from modifying production projects. You want to manage policies for all projects centrally and be able to set more restrictive policies for production projects. You want to minimize disruption to users and developers when business needs change in the future. You want to follow Google recommended practices. Now should you design the organization structure? A1. Create a second Google Workspace account and organization. 2. Grant all developers the project creator IAM role on the new organization. 3. Move the developer projects into the new organization. 4. Set the policies for all projects on both organizations. 5. Additionally, set the production policies on the original organization. B1. Create a folder under the organization resource named europroduction.euro2. Grant all developers the project creator IAM role on the new organization. 3. Move the developer projects into the new organization. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the Europroduction Euro folder. CA1. Create folders under the organization resource named Eurodevelopment Euro and Europroduction.euro2. Grant all developers the project creator IAM role on the Eurodevelopment Euro folder. 3. Move the developer projects into the Eurodevelopment Euro folder. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the Europroduction Euro folder. D1. Designate the organization for production projects only. 2. Ensure that developers do not have the project creator IAM role on the organization. 3. Create development projects outside of the organization using the developer Google Workspace accounts. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the individual production projects. The best approach is option C. 1. Create folders under the organization resource named Development and Production. 2. Grant all developers the project creator IAM role on the Development folder. 3. Move the developer projects into the Development folder. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the Production folder. Explanation. This approach follows Google recommended practices for managing resources in a scalable and organized manner. Creating folders under the organization resource allows for logical separation of development and production environments. Policies can be centrally managed at the organization level and made more restrictive at the folder level. Developers are granted permissions to create projects only in the development folder, ensuring production projects remain protected from unauthorized changes. Why other options are less suitable? Option A suggests creating a second Google Workspace account and organization, which increases complexity and operational overhead. Managing two organizations requires duplicating policies and processes, which is unnecessary and against best practices. Option B is partially correct but includes an unnecessary step of creating a new organization, which is not required. A single organization with separate folders for development and production is sufficient and more efficient. Option D advocates for creating development projects outside of the organization. This undermines centralized management and control, leading to inconsistent policies and potential security risks. Conclusion. Option C is the best choice as it ensures centralized management, logical resource separation, and minimal disruption to developers while adhering to best practices. Question 172. Your company has an application running on Compute Engine that allows users to play their favorite music. There are a fixed number of instances. Files are stored in cloud storage, and data is streamed directly to users. Users are reporting that they sometimes need to attempt to play popular songs multiple times before they are successful. You need to improve the performance of the application. What should you do? A1. Mount the cloud storage bucket using GCSFUs on all backend compute engine instances. 2. Serve music files directly from the backend compute engine instance. B1. Create a cloud file store NFS volume and attach it to the backend compute engine instances. 2. Download popular songs in Cloud File Store. 3. Serve music files directly from the backend compute engine instance. C1. Copy popular songs into Cloud SQL as a blob. 2. Update application code to retrieve data from Cloud SQL when cloud storage is overloaded. D1. Create a managed instance group with compute engine instances. 2. Create a global load balancer and configure it with 2 backends, managed instance group, cloud storage bucket 3. Enable Cloud CDN on the bucket backend. The best approach is option D. 1. Create a managed instance group with compute engine instances. 2. Create a global load balancer and configure it with 2 backends. Managed instance group. Cloud storage bucket. 3. Enable Cloud CDN on the bucket backend. Explanation. This solution improves performance and reliability by leveraging a global load balancer and enabling Cloud CDN for caching. Here's why this is the best choice. 1. Global load balancer distributes user requests efficiently across multiple backends, ensuring that the system can handle spikes in traffic. By using 2 backends, the instance group and cloud storage, the load balancer can dynamically route traffic to the most appropriate source. 2. Cloud CDN caches popular content closer to users, reducing latency and the load on backend systems. This improves the likelihood of successful playback of popular songs even under high demand. 3. Managed instance group ensures scalability and fault tolerance for backend operations if dynamic application logic is required. Why other options are less suitable? Option A. Using GCSFUs adds significant overhead, as it is not optimized for high-performance streaming. This approach does not address the need for scalability or caching, which are critical for improving playback success rates. Option B. Cloud File Store is designed for file-sharing use cases, not for serving content to a large number of users. Storing and serving files directly from Cloud File Store is inefficient and costly compared to cloud storage with CDN. Option C. Storing media files in Cloud SQL as blobs is not a recommended practice. Cloud SQL is optimized for structured relational data, not for serving large binary objects. This approach would increase costs and degrade performance. Conclusion. Option D is the optimal solution as it provides a scalable, reliable, and high-performance architecture. It uses a global load balancer, cloud storage, and Cloud CDN to efficiently serve music files to users, minimizing playback issues and enhancing user experience. Question 173. The operations team in your company wants to save Cloud VPN log events for 1 year. You need to configure the cloud infrastructure to save the logs. What should you do? A. Set up a filter in cloud logging and a cloud storage bucket as an export target for the logs you want to save. Most voted. B. Enable the Compute Engine API, and then enable logging on the firewall rules that match the traffic you want to save. C. Set up a cloud logging dashboard titled Cloud VPN Logs, and then add a chart that queries for the VPN metrics over a 1-year time period. D. Set up a filter in cloud logging and a topic in PubSub to publish the logs. The best approach is option A. Set up a filter in cloud logging and a cloud storage bucket as an export target for the logs you want to save. Explanation. Saving logs for an extended period, such as 1 year, is best achieved by exporting them from cloud logging to a durable and cost-effective storage solution like cloud storage. Here's why this approach works. 1. Filtering specific logs. Cloud logging allows you to define filters to export only the relevant Cloud VPN log events. This ensures that you save only the required data, optimizing storage costs. 2. Cloud storage for long-term retention. Cloud storage is designed for long-term and secure storage. It supports lifecycle policies to manage log retention and offers cost-efficient storage classes, example, nearline or cold line, for infrequently accessed logs. 3. Durability and availability. Cloud storage provides high durability, ensuring that the logs are preserved for the required 1-year period. Why other options are less suitable? Option B. Enabling the Compute Engine API and logging on firewall rules is unrelated to Cloud VPN logs. This does not address the requirement to save VPN logs for 1 year. Option C. Setting up a dashboard with charts provides a visual representation of VPN metrics but does not address log retention. Dashboards are meant for monitoring and visualization, not long-term storage. Option D. Exporting logs to a pub subtopic is useful for real-time streaming and integration with other systems but is not suitable for long-term retention. Logs would still need to be stored elsewhere. Conclusion. Option A is the optimal solution as it ensures efficient, secure, and cost-effective long-term storage of Cloud VPN log events for 1 year, following Google Cloud's best practices. Question 174. You are working with a data warehousing team that performs data analysis. The team needs to process data from external partners, but the data contains personally identifiable information, PII. You need to process and store the data without storing any of the PI data. What should you do? A. Create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, use the Cloud Data Loss Prevention (Cloud DLP) API to remove any PII data. Store the result in BigQuery. B. Create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, store all non-PII data in BigQuery and store all PII data in a cloud storage bucket that has a retention policy set. C. Ask the external partners to upload all data on cloud storage. Configure bucket lock for the bucket. Create a data flow pipeline to read the data from the bucket. As part of the pipeline, use the Cloud Data Loss Prevention (Cloud DLP) API to remove any PII data. Store the result in BigQuery. D. Ask the external partners to import all data in your BigQuery dataset. Create a data flow pipeline to copy the data into a new table. As part of the data flow bucket, skip all data in columns that have PII data. The best approach is option A. Create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, use the Cloud Data Loss Prevention (Cloud DLP) API to remove any PII data. Store the result in BigQuery. Explanation. This approach aligns with Google Cloud's best practices for handling data containing personally identifiable information, PII. Here's why. 1. Cloud Data Loss Prevention (Cloud DLP). Cloud DLP is specifically designed to identify and remove sensitive information, such as PII. Integrating it into the data flow pipeline ensures that sensitive data is removed before storage. 2. BigQuery for analytics. BigQuery is an ideal choice for storing and analyzing non-PII data due to its scalability, performance, and integration with Google Cloud tools. 3. Data flow for processing. Dataflow is a managed service for stream and batch data processing. Using it to retrieve, process, and sanitize the data ensures efficient handling of the data pipeline. 4. Compliance and security. By removing PII before storing the data, the solution complies with data protection regulations and minimizes risk in case of unauthorized access to the stored data. Why other options are less suitable? Option B. Storing PII in a cloud storage bucket, even with a retention policy, increases the risk of exposure and contradicts the requirement to avoid storing PII. Option C. While this option uses Cloud DLP, it involves an additional and unnecessary step of asking external partners to upload data to cloud storage. Direct retrieval via the pipeline is more efficient and secure. Option D. Importing data with PII into BigQuery violates the requirement to avoid storing PII. BigQuery datasets should only contain sanitized, non-sensitive data to comply with security and privacy regulations. Conclusion. Option A is the best solution because it ensures that PII is removed before storage while leveraging Google Cloud's tools for data processing and analysis. This approach satisfies the requirement to avoid storing PII and adheres to best practices for data security and compliance. Question 175. You want to allow your operations team to store logs from all the production projects in your organization, without including logs from other projects. All of the production projects are contained in a folder. You want to ensure that all logs for existing and new production projects are captured automatically. What should you do? A. Create an aggregated export on the production folder. Set the log sync to be a cloud storage bucket in an operations project. B. Create an aggregated export on the organization resource. Set the log sync to be a cloud storage bucket in an operations project. C. Create log exports in the production projects. Set the log syncs to be a cloud storage bucket in an operations project. D. Create log exports in the production projects. Set the log syncs to be BigQuery datasets in the production projects, and grant IAM access to the operations team to run queries on the datasets. The best approach is option A. Create an aggregated export on the production folder. Set the log sync to be a cloud storage bucket in an operations project. Explanation. An aggregated export at the folder level is the most efficient and scalable way to capture logs from all production projects without including logs from other projects. Here's why this solution is the best. 1. Aggregated exports. Configuring an aggregated log sync at the folder level ensures that logs from all existing and newly created projects within the folder are automatically captured. This eliminates the need to configure individual log exports for each project. 2. Scope to production projects. By setting the export at the production folder level, you capture logs only from projects in that folder. This avoids unnecessary inclusion of logs from other non-production projects. 3. Centralized log storage. Sending logs to a cloud storage bucket in an operations project centralizes log management and ensures that the operations team can access all production logs without having to configure access across multiple projects. 4. Cost and complexity. This approach is cost-effective and simpler to maintain than creating and managing separate log exports for individual projects. Why other options are less suitable? Option B. Creating an aggregated export at the organization level would include logs from all projects, not just production projects. This contradicts the requirement to capture logs only from production projects. Option C. Configuring log exports individually in each production project increases administrative overhead and makes it difficult to ensure consistency. Adding new production projects would require manual configuration of log exports. Option D. Using BigQuery datasets in each production project complicates centralized log management. Granting IAM access to the operations team across multiple datasets is less efficient and does not automatically include new projects. Conclusion. Option A is the optimal solution because it ensures automatic, efficient, and centralized capture of logs from all production projects while meeting the requirement to exclude logs from other projects. This approach adheres to best practices for log management in Google Cloud. Question 176. Your company has an application that is running on multiple instances of compute engine. It generates 1 terabyte per day of logs. For compliance reasons, the logs need to be kept for at least 2 years. The logs need to be available for active query for 30 days. After that, they just need to be retained for audit purposes. You want to implement a storage solution that is compliant, minimizes costs, and follows Google recommended practices. What should you do? A1. Install a cloud logging agent on all instances. 2. Create a sync to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a cold line cloud storage bucket after 1 month. 4. Configure a retention policy at the bucket level using bucket lock. B1. Write a daily cron job, running on all instances, that uploads logs into a cloud storage bucket. 2. Create a sink to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a cold-line cloud storage bucket after 1 month. C. 1. Install a cloud logging agent on all instances. 2. Create a sink to export logs into a partitioned BigQuery table. 3. Set a time_partitioning_expiration of 30 days. D1. Create a daily cron job, running on all instances, that uploads logs into a partitioned BigQuery table. 2. Set a time_partitioning_expiration of 30 days. The best approach is option A. 1. Install a cloud logging agent on all instances. 2. Create a sink to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a cold-line cloud storage bucket after 1 month. 4. Configure a retention policy at the bucket level using bucket lock. Explanation. This solution balances cost, compliance, and active query availability while adhering to Google recommended practices. 1. Cloud logging agent. Installing the cloud logging agent ensures logs are automatically collected from all instances without requiring custom scripts. It supports high-volume log generation and is integrated with Google Cloud Logging. 2. Regional cloud storage bucket. Exporting logs to a regional bucket allows for cost-effective storage and quick access for active querying during the 30-day period. 3. Cold-line storage transition. The object lifecycle rule moves logs to a cold-line storage bucket after 30 days, significantly reducing storage costs for long-term retention. Cold-line is ideal for infrequently accessed data such as logs retained for audit purposes. 4. Retention policy with bucket lock. A retention policy ensures compliance by preventing logs from being deleted before the 2-year retention period ends. Bucket lock enforces the retention policy, making it immutable to accidental changes. Why other options are less suitable? Option B. Writing a daily cron job to upload logs adds unnecessary complexity and operational overhead. Additionally, this option does not mention retention compliance using bucket lock, making it less reliable. Option C. Exporting logs to BigQuery for active querying is suitable for short-term needs, but using BigQuery for long-term retention, beyond 30 days, is costlier than cloud storage, especially for audit purposes. BigQuery is optimized for analytics, not archival storage. Option D. This option relies on a daily cron job and BigQuery, which increases operational complexity and costs for long-term retention. It does not address the need for cost-effective, long-term archival storage. Conclusion. Option A is the best solution because it ensures compliance, minimizes costs by transitioning logs to cold-line storage after 30 days, and supports active querying during the initial period. This approach adheres to Google Cloud's best practices for log management and storage. Question 177. Your company has just recently activated Cloud Identity to manage users. The Google Cloud organization has been configured as well. The security team needs to secure projects that will be part of the organization. They want to prohibit IAM users outside the domain from gaining permissions from now on. What should they do? A. Configure an organization policy to restrict identities by domain. B. Configure an organization policy to block creation of service accounts. C. Configure Cloud Scheduler to trigger a cloud function every hour that removes all users that don't belong to the Cloud Identity domain from all projects. D. Create a technical user, example crawler at yourdomain.com, and give it the project owner role at root organization level. Write a bash script that Eurocentiers lists all the IAM rules of all projects within the organization. Eurocentiers deletes all users that do not belong to the company domain. Create a compute engine instance in a project within the organization and configure gcloud to be executed with technical user credentials. Configure a cron job that executes the bash script every hour. The best approach is option A. Configure an organization policy to restrict identities by domain. Explanation. Restricting identities by domain using an organization policy is the most efficient, secure, and Google recommended solution to prevent IAM users outside your company's domain from gaining permissions. This policy ensures that only users within the cloud identity domain can access the projects under the organization, and it applies consistently across all projects. 1. Organization policy. Google Cloud offers a specific constraints IAM.allowed policy member domains, that enforces restrictions on IAM policies by domain. This prevents users or groups from external domains from being granted access to resources, ensuring compliance with the security team's requirements. 2. Centralized control. Organization policies are enforced at the organization level and propagate automatically to all projects within the organization, including new ones. This eliminates the need for manual intervention or periodic scripts. 3. Ease of maintenance. Once configured, the organization policy requires minimal maintenance and automatically enforces security measures, even as new projects or roles are created. Why other options are less suitable? Option B. Blocking the creation of service accounts does not address the requirement to prohibit IAM users from outside the domain. Service accounts are a separate concern and not directly related to this scenario. Option C. Configuring a cloud scheduler to trigger a cloud function every hour to remove external users is inefficient, operationally complex, and error-prone. It also introduces delays between when an external user is granted access and when they are removed. Option D. Using a technical user with a script to manually scan and remove external users is highly inefficient, difficult to maintain, and prone to errors. This approach is overly complex and not aligned with Google Cloud's best practices for security management. Conclusion. Option A is the optimal solution because it leverages Google Cloud's built-in organization policies to enforce security at the organizational level. It is simple to implement, easy to maintain, and provides robust and consistent protection against unauthorized access by users outside the company's domain. Question 178. Your company has an application running on Google Cloud that is collecting data from thousands of physical devices that are globally distributed. Data is published to PubSub and streamed in real time into an SSD cloud Bigtable cluster via a data flow pipeline. The operations team informs you that your cloud Bigtable cluster has a hotspot, and queries are taking longer than expected. You need to resolve the problem and prevent it from happening in the future. What should you do? A. Advise your clients to use HBase APIs instead of Node.js APIs. B. Delete records older than 30 days. C. Review your Roki strategy and ensure that keys are evenly spread across the alphabet. D. Double the number of nodes you currently have. The best approach is option C. Review your Roki strategy and ensure that keys are evenly spread across the alphabet. Explanation. Cloud Bigtable's performance can degrade if there are hotspots, which typically occur when a large number of requests target the same set of rows. This happens when the Roki design is not optimal and causes many queries to access a limited range of data. By ensuring that Rokis are distributed evenly across the data, you can mitigate hotspots. 1. Roki strategy. The Roki is the primary way data is distributed across the cloud Bigtable nodes. If the Rokis are not distributed evenly, all traffic can be directed to a small subset of the nodes, causing hotspots, overloaded regions that slow down performance. Distributing Rokis evenly across the alphabet or using hash-based keys can help avoid this issue. 2. Prevents future hotspots. Optimizing Roki strategy ensures that data is balanced and queries are evenly distributed, which prevents hotspots from reoccurring. Why other options are less suitable? Option A. Switching APIs, HBase versus Node.js, does not address the underlying issue of data distribution or hotspotting. The problem lies in how the data is stored and queried, not in the choice of API. Option B. Deleting records older than 30 days may help free up space but does not resolve the issue of hotspotting. The root cause of hotspotting is the way data is distributed, not the age of the data. Option D. Doubling the number of nodes increases the resources available to the system but does not address the core issue of hotspotting caused by poor Roki design. This could temporarily alleviate the problem but won't scale effectively if the Roki strategy is still flawed. Conclusion. Option C is the best solution because it directly addresses the root cause of the performance issue, hotspots due to poor Roki distribution. By optimizing the Roki design to ensure even distribution, you can effectively resolve the problem and prevent it from recurring in the future. Question 179. Your company has a Google Cloud project that uses BigQuery for data warehousing. There are some tables that contain personally identifiable information, PII. Only the compliance team may access the PII. The other information in the tables must be available to the data science team. You want to minimize cost and the time it takes to assign appropriate access to the tables. What should you do? A1. From the dataset where you have the source data, create views of tables that you want to share, excluding PII. 2. Assign an appropriate project-level IAM role to the members of the data science team. 3. Assign access controls to the dataset that contains the view. B1. From the dataset where you have the source data, create materialized views of tables that you want to share, excluding PII. 2. Assign an appropriate project-level IAM role to the members of the data science team. 3. Assign access controls to the dataset that contains the view. CA1. Create a dataset for the data science team. 2. Create views of tables that you want to share, excluding PII. 3. Assign an appropriate project-level IAM role to the members of the data science team. 4. Assign access controls to the dataset that contains the view. 5. Authorize the view to access the source dataset. D1. Create a dataset for the data science team. 2. Create materialized views of tables that you want to share, excluding PII. 3. Assign an appropriate project-level IAM role to the members of the data science team. 4. Assign access controls to the dataset that contains the view. 5. Authorize the view to access the source dataset. The best approach is option C. Explanation. This approach ensures that the data science team can access the relevant data without being exposed to PII, while the compliance team can continue to access the sensitive data. Here's why this is the best solution. 1. Views. By creating views that exclude PII, you ensure that the data science team only gets access to the non-sensitive data. Views provide a convenient way to abstract data, enabling you to control exactly what is exposed to different teams. 2. Dedicated dataset for data science team. Creating a separate dataset for the data science team ensures proper separation of concerns. This makes it easier to manage permissions and access controls for different teams and data sets. 3. Access controls. You can set dataset-level access controls to grant the data science team access only to the views they need, and to the compliance team access to the original tables containing PII. 4. Authorization of views. Authorizing the view to access the source dataset ensures that the data science team can still query the source data through the view without direct access to the underlying tables containing PII. 5. Minimizing cost and time. Views are cost-effective as they don't involve duplication of data. This minimizes the storage costs compared to materialized views. Moreover, using dataset-level permissions simplifies access management. Why other options are less suitable? Option A. While this option involves creating views and assigning access to the dataset containing those views, it doesn't suggest using a dedicated dataset for the data science team. Managing permissions across multiple datasets without separation might become difficult as the number of views or teams grows. Option B. Materialized views store the results of a query, leading to higher storage costs. They also involve more complexity in terms of refreshing and managing the materialized view, which is unnecessary if a simple view can achieve the goal. Option D. Similar to option B, materialized views add unnecessary complexity and cost. Additionally, authorizing the view to access the source dataset is only useful if materialized views are involved. Since views, not materialized views, suffice in this case, this option is more complicated than needed. Conclusion. Option C is the best approach because it simplifies the setup by using views, minimizes cost by avoiding materialized views, and ensures that access is properly segregated between the data science and compliance teams. This approach provides a scalable and efficient solution for managing access to both sensitive and non-sensitive data in BigQuery. Question 180. Your operations team currently stores 10 terabits of data in an object storage service from a third-party provider. They want to move this data to a cloud storage bucket as quickly as possible, following Google recommended practices. They want to minimize the cost of this data migration. Which approach should they use? A. Use the xutil-mv command to move the data. B. Use the storage transfer service to move the data. C. Download the data to a transfer appliance and ship it to Google. D. Download the data to the on-premises data center and upload it to the cloud storage bucket. The best approach is option B. Use the storage transfer service to move the data. Explanation. The storage transfer service is a fully managed service designed for efficiently transferring large amounts of data from external sources, such as third-party object storage services, into Google Cloud Storage. It is the best choice for the following reasons. 1. Speed. The storage transfer service is optimized for large-scale data transfers and can leverage Google Cloud's fast network infrastructure to move data efficiently, minimizing the overall time required for the migration. 2. Cost efficiency. The service offers competitive pricing and optimizes data transfer without requiring additional infrastructure or manual effort, which keeps the costs lower compared to other methods. 3. Automation. The service supports scheduling and automating transfers, allowing the operations team to initiate, monitor, and complete the migration process with minimal manual intervention. This improves the efficiency and scalability of the migration. 4. Google recommended. This is the recommended method for large data migrations into cloud storage from external sources, as it is designed specifically for such use cases and integrates well with Google Cloud tools. Why other options are less suitable? Option A. xutil-mv command. While xutil-mv can be used to move data between cloud storage locations, it is not suited for migrating data from third-party object storage services. It also requires the data to be already accessible from Google Cloud, which is not the case here. Option C. Transfer appliance. While a transfer appliance is useful for transferring petabytes of data from on-premises environments or when network bandwidth is limited, it is unnecessary for transferring 10 terabits of data from a third-party provider. This method also involves shipping hardware, adding complexity and additional costs. Option D. Download to on-premises and upload. This method is the most manual and inefficient. It requires downloading the data to an on-premises location and re-uploading it to Google Cloud, which introduces unnecessary bandwidth costs, delays, and operational overhead. Conclusion. Option B, using the storage transfer service, is the best approach for efficiently and cost-effectively migrating 10 terabits of data from a third-party object storage service to Google Cloud Storage, following Google recommended practices.